Yeah, good morning and welcome back, my friends. See, we are again continuing our discussions on the C Sharp programming and .NET framework. So far, we have uploaded two chapters of C Sharp programming and .NET. So today I am uploading C Sharp programming and .NET chapter 3 of 96. Chapter 3 of 96. This video also deals extensively with the basic theory which led to the evolution of the .NET framework. It's a must that you should follow these theoretical concepts very closely because that is needed for understanding the importance of the .NET framework in comparison with Microsoft's previous technology of Windows. So the .NET framework is a drastic deviation and an improvement from the earlier Windows technology. So you please go through this theory very closely. Maybe one more set of video will be like this. After that, I will be starting the programming part. And please be advised that this course is very rich in programs. This course contains more than 150 programming exercises, 150 plus exercises in C Sharp exercises. So, before going to the actual programming part, it's a must that you should understand the basic theory very well. That's why I am elaborating the theory much in these earlier videos. So, happy programming. So, here also you concentrate on this theory very well and understand the basics because it's an absolute must before learning the concepts of .NET framework. You should know the theory that led to the evolution of the .NET framework. Fine. Yeah, now let us discuss single file and multi-file assemblies. Single file and multi-file assemblies. Okay. In a great number of cases, comma, there is a simple one-to-one correspondence between a .NET assembly and the binary file. That is star.dll or star.exe file. Close the bracket, full stop. Thus, if you are building a .NET star.dll, it is safe to consider that the binary and the assembly are one and the same. The binary and the assembly are one and the same. Full stop. Likewise, if you are building an executable desktop application, comma, the star.exe can be simply referred to as the assembly itself, full stop. Technically speaking, comma, if an assembly is composed of a single star.dll or star.exe module, if an assembly is composed of a single star.dll or star.exe module, you have a single file assembly. See, in that case, you have a single file assembly, full stop. Single file assemblies contain all the necessary CIL, metadata, and associated manifest in an autonomous, single well-defined package. In an autonomous, single, well-defined package. Full stop. Next. Multi-file assemblies, on the other hand, are composed of numerous .NET binaries, each of which is termed a module. Full stop. When building a multi-file assembly, one of these modules, in bracket I mentioned, termed the primary module. termed the primary module, close the bracket, must contain the assembly manifest, in bracket again I have put, and possibly CIL instructions and metadata for various types, full stop. The other related modules contain a module level manifest. The other related modules contains a module level manifest, comma, CIL and type metadata, Fine. Yeah, now the role of the common intermediate language, that is CIL, common intermediate language or CIL. The role of the common intermediate language. CIL is a language that sits above any particular platform specific instruction set, full stop. That sits above any particular platform specific instruction set, full stop. Regardless of which .NET aware language you choose, comma, the associated compiler emits CIL instructions. You know it. The associated compiler will emit CIL instructions, full stop. Let us investigate the benefits of compiling source codes to CIL, into CIL, comma, rather than directly to a specific instruction set. Full stop. One obvious benefit is language integration. That's the most important thing. One obvious benefit is language integration, full stop. As you have already understood, comma, each .NET aware compiler produces nearly identical CIL instructions. Full stop. Next. Therefore, all languages are able to interact within a well-defined binary arena. That's it. Therefore, all languages are able to interact within a well-defined binary arena. Full stop. Furthermore, comma, given that CIL is platform agnostic, comma, the .NET framework itself is platform agnostic, comma, providing the same benefits Java developers have. Full stop. That is a single code base running on different OSs. That's exactly what is happening in the case of Java. That is a single code base running on different OSs, full stop. In fact, there is an international standard for the C# language, and a large subset of the .NET platform and implementations already exist for many non-window OSs. Full stop. Again, in contrast to Java, comma, however, .NET allows you to build applications using your language of choice. That is the most important point. Again, in contrast to Java, comma, however, .NET allows you to build applications using your language of choice. Fine. That's the most important point, right? Yeah, compiling CIL to platform specific instructions. Now let us consider how compiling CIL to platform specific instructions work. How it works. Okay, fine. Due to the fact that assemblies contain CIL instructions rather than platform specific instructions, comma, CIL code must be compiled on the fly before use. CIL code must be compiled on the fly before use, full stop. The entity that compiles CIL code into meaningful CPU instructions pertaining to a particular processor is termed a just-in-time compiler. A just-in-time compiler, or in bracket I have put JIT compiler, comma, which is also called jitter, full stop. The .NET runtime environment leverages a JIT compiler for each CPU, comma, targeting the runtime, comma, each optimized for the underlying platform. Full stop. For example, comma, if you are building a .NET application that is to be displayed to a handheld device, such as a pocket device, etc., comma, the corresponding jitter is well equipped to run within a low memory environment. The corresponding jitter is well equipped to run within a low memory environment. Full stop. On the other hand, if you are deploying your assembly to a backend server where memory is seldom an issue, comma, the jitter will be optimized to function in a high-end memory environment. It will be optimized to function in a high-end memory environment. Full stop. In this way, developers can write a single body of code that can be efficiently JIT compiled and executed on machines with different architectures. That's it. Fine. Yeah, understanding the common type system, that is CTS. Fine. A given assembly may contain any number of distinct types. See, types I have put with a double quote. Full stop. In .NET terminology, type is simply a generic term used to refer to a member of the set within braces or within angle brackets. Sorry, within curly brackets. See, there are 5 types. Look, class, comma, structure, comma, interface, comma, enumeration, comma, and delegate. Close the curly bracket. Look. So this set enclosed in curly brackets contains 5 elements. Look. One is class, comma, structure, comma, interface, comma, enumeration, comma, and delegate. So that means 5 types are there. There are 5 such types. 1, 2, 3, 4, 5. 5. So together these types, it is generally termed a type. Each one is a type. It can be either a class type, a structure type, or an interface type, or an enumeration type, or even a delegate type. It's a very important concept in C#. Now look. The CTS, in bracket, common type system, is a formal specification that documents how types must be defined in order to be hosted by the CLR. Then full stop. It's important, however, for all .NET programmers to learn about how to work with the 5 types, the types which I already explained, with the 5 types defined by the CTS in their language of choice. Following is a brief overview. It's important. Following is a brief overview. Fine. Now look. Yeah, we already saw that there are 5 such types. 5 types. The first one is the class type. See, there are 5 types, of which the first one is class types. So we will just have, see, we will go through each one by one, each type one by one. Look, first one, we will go through class type 1, CTS class types. Every .NET aware language supports at the very least, comma, the notion of a class type. The notion of a class type. It's very fundamental in every .NET aware language, the notion or the concept of a class type, full stop, comma, which is the cornerstone of object-oriented programming, full stop. Class type is the cornerstone of object-oriented programming, full stop. A class may be composed of any number of members. A class may be composed of any number of members, in bracket I have kept, such as properties, comma, methods and events, close the bracket, and data points or fields, and data points or fields. In bracket I have kept fields, full stop. In C#, classes are declared using the class keyword. Using the class keyword. Fine. See, see a comment, a C# class type. Look, public class calc. The name of the class is calc. We are using the keyword class, CLASS class. The name of the class here is calc. Open the brace, next line. Then we are keeping one function by name add. Public int. The int is the return type. Int add, in bracket int x, comma int y. 2 arguments of type int x, comma int y, close the bracket. Next, open the brace. We are defining the function. Open the brace, return x plus y, semicolon. Then next line, close the brace. Actually, we are now closing the definition part of the function add. Then after that, close the brace. For the class calc, the closing brace for the class calc. Fine. These are all very simple because you have gone through the concept of a class many times. Fine. That's it. Yeah, now let us discuss class characteristics. Class characteristics. See point number 1. Is the class sealed or not? Is the class sealed or not? Look, sealed classes cannot function as a base class to other classes. Yeah, sealed classes cannot function as a base class to other classes. See point number 2. Does the class implement any interfaces? Does the class implement any interfaces? Look, an interface is a collection of abstract members that provide a contract between the object and the object user. Between the object and the object user, full stop. The CTS allows a class to implement any number of interfaces. The CTS allows a class to implement any number of interfaces, full stop. See point number 3. Is the class abstract or concrete? Is the class abstract or concrete? Abstract classes cannot be directly created, comma, but are intended to define common behaviors for the derived classes. Common behaviors for the derived classes, full stop. Concrete classes can be created directly. Fine. See the fourth point, 4. What is the visibility of this class? What is the visibility of this class? Full. See, each class must be configured with a visibility attribute, say private, public, etc. So you know the meaning of private, public, etc. Fine. That's it. Yeah, the next type we are considering is a structure, the structure types. So 2 CTS structure types. We are now considering the structure types. 2 CTS structure types. Look, the concept of a structure is also formalized under the CTS. That is also formalized under the CTS. Full stop. Simply put, comma, structures can be thought of as a lightweight class type having value-based semantics. That is it. Simply put, structures can be thought of as a lightweight class type having value-based semantics. Full stop. Now we are giving a small example for a structure. Look, the name of the structure is point. So the keyword struct point. So we are using the keyword struct for defining a structure. Struct point. A comment I have put a C# structure type. A C# structure type. Then next line, open the brace. Open the brace. Then we are actually defining some fields. Look, public int x pos, comma y pos, semicolon. Look, structures can contain fields. These two fields, the field named x pos and the field named y pos. It is declared as, see, int, public int x pos, comma y pos, semicolon. So structures can contain fields. Okay, fine. Next is actually a constructor, a parameterized constructor. Look, public point in bracket int x, comma int y, close the bracket. See, structures can contain parameterized constructors. See, that's also absolutely valid. Structures can contain parameterized constructors. Then next line, open the brace. Then x pos is equal to x, semicolon. Next, y pos is equal to y, semicolon. Next line, close the brace. We are closing the brace for the constructor point. That is the parameterized constructor. So that has been closed here. Next, we are considering another method. Look, public void display. Display is a method. Look, structures may define methods. It can have even methods. Public void display. Structures can define methods. Next line, open the brace. Then console.writeLine in bracket. Within double quote, 0 within braces, comma, again 1 within braces. Then that much is within double quote, comma, x pos, comma, y pos, close the bracket. Then semicolon. Fine. It's very simple. The content of x pos will come and sit at the point where 0 is mentioned, and the content of y pos will come and sit at the point where 1 is mentioned. Both 0 and 1 are kept within curly braces. Fine. All those things are basic, So after that, put semicolon. Next line. Close the brace for the function or method display. So the method display is coming to an end at this point. After that, the last one is again closing brace for the structure point. Structure point is now getting closed at this point. So the structure also we are closing at this point. This is the closing brace corresponding to the structure point or struct point. Fine. That's it. Very simple. Yeah, now we are considering what is called interfaces, interface types. So 3 CTS interface types. There are 5 types already. We have discussed the other 2. This is the third. So 3 CTS interface types. Now look, interfaces are nothing more than a named collection of abstract member definitions which may be implemented by a given class or structure. Full stop. Unlike in COM, .NET interfaces do not derive from a common base interface such as IUnknown. Don't worry about this IUnknown and all those things. We are not going to have any discussions on IUnknown. It's a purely COM terminology. We are not using COM as such in our .NET discussions. So this IUnknown is a purely COM terminology. Don't worry. Full stop. In C#, interfaces are defined using the interface keyword. Using the keyword interface. Full stop. Using the interface keyword. Full stop. Now we are giving a small example. Look. Public interface. We are using the keyword interface. Public interface iDraw. The name of the interface is iDraw. See, A C sharp interface type, a comment I have put, a C sharp interface type. Then next line, open the brace. Then the associated function we are giving here, void draw, semicolon. The function is void, it returns nothing, so void draw. Then after that semicolon, next the closing brace, fine. This is actually a very simple draw function. Next, after that the closing brace, fine. See, now we'll give some explanations. On their own, look, on their own, comma, interfaces are of little use. Interfaces are of little use, full stop. On their own, fine. However, when a class or structure implements a given interface in its own unique way, comma, you are able to request access to the supplied functionality using an interface reference in a polymorphic manner. It's very important. See, access to the supplied functionality using an interface reference. In a polymorphic manner. Okay, we'll see the examples and then it will be very clear to you. Fine. Yeah, now we are considering the enumeration types. See, that's it. The fourth type we are considering is for CTS enumeration types. Okay. Fine, look. Enumerations are a handy programming construct that allows you to group name-value pairs. Name-value pairs. Full stop. Imagine a video game application that allows the player to select one of three character categories like wizard, fighter, or thief. The categories are wizard, fighter, or thief. Full stop. Rather than keeping track of raw numerical values to represent each possibility, you could build a custom enumeration using enum keyword as enter. We are using the enum keyword for that. Enum keyword as enter. Look, public, one example I am showing here. Public enum character type. Next, open the brace. Wizard is equal to 100, fighter is equal to 200, thief is equal to 300. Fine. We are given for numerical values, we are given the names like wizard for 100, fighter for 200, and thief for 300. Next line, close the brace. Fine. It's very simple. By default, the storage used to hold each item is a 32-bit integer. However, it is possible to alter this storage slot if necessary. In bracket. For example, when programming for a low memory device such as a pocket PC or such as a mobile or whatever be, a pocket device such as a pocket PC or a pocket device. Fine. It's that very simple. Yeah, now we are considering the last type. Yeah, that is 5, CTS delegate type. The last type we are considering is delegate type. So 5, CTS delegate type. Now look, delegates are the .NET equivalent of a type safe C-style function pointer. Look, that is it. It is the .NET equivalent of a type safe C-style function pointer. Full stop. The key difference is that a .NET delegate is a class that derives from system.multicast delegate. Rather than a simple pointer to a raw memory address. Full stop. In C#, delegates are declared using the delegate keyword. In C sharp, delegates are declared using the delegate keyword. We are now declaring one delegate. See, delegates, we are now declaring one delegate. Before that, look, this comment you please look at comment. This C sharp delegate type can point to any method returning an integer and taking two integers as input. This particular C sharp delegate type can point to any method returning an integer and taking two integers as input. Next, see the declaration is like this: public, see the keyword delegate, public delegate, int, the return type int, binary op, the name of the delegate is binary op, in bracket we are passing two variables, two arguments of type int x comma int y, close the bracket, semicolon. That's it. Public delegate int binary op in bracket int x comma int y, close the bracket, semicolon. Fine. Delegates are useful when you wish to provide a way for one entity to forward a call to another entity. See, that's it. Delegates are useful when you wish to provide a way for one entity to forward a call to another entity, comma, and provide the foundations for the .NET event architecture, and provide the foundations for the .NET event architecture. Fine. Yeah. CTS type members. CTS type members. Fine. Now observe that most types take any number of members. We have already seen it. Now observe that most types take any number of members. Full stop. Formally speaking, comma, a type member is constrained by the set. It is actually constrained by the set within braces or curly bracket. See, constructor, comma, finalizer, comma, static constructor, comma, nested type, comma, operator, comma, method, comma, property, comma, indexer, comma, field, comma, read-only field, comma, constant, comma, event. That much. Close the brace or curly bracket. Close the curly bracket. So this is the set. Okay, fine. The CTS defines various adornments that may be associated with a given member. That also is there. The CTS defines various adornments that may be associated with a given member. Full stop. Next. For example, each member has a given visibility trait like private, comma, public, comma, protected, etc. Public, private, protected, etc. Full stop. Some members may be declared as abstract to enforce polymorphic behavior on derived types, as well as virtual to define a canned, that means in bracket, but overridden implementation. A canned or overridden implementation, but overridden implementation, full stop. Also, most members may be configured as static, bound at the class level, in bracket, bound at the class level, close the bracket, or instance, that is bound at the object level, or instance, that is in bracket again, bound at the object level. Fine. I think it's fine. Yeah, we will consider the so-called intrinsic CTS data types. Intrinsic CTS data types. Fine. The core data types defined by CTS is as under. The core data types defined by CTS is as under. Look. CTS data type and corresponding C sharp keyword. You are now CTS data type first and then its corresponding C sharp keyword. Fine. System.byte, B capital, system.byte. So its C sharp keyword is byte. These are all small letters, all lowercase letters, byte. Fine. System.s byte, that is signed byte, for signed byte. System.s byte, S byte. S byte is nothing but signed byte. Next, system.int16. System.int16. That is actually short. We are familiar with short. Then system.int32. Most of the time we are using this data type. System.int32 is our int, simply int. System.int64 is our long. Okay, fine. System.uint16, that is unsigned int 16. That is nothing but u short, that is unsigned short. Again, system.uint32, that is unsigned int 32. Unsigned int, that is unsigned int and unsigned int. Okay, fine. Next, system.uint64 or unsigned int 64. That is u long, that is unsigned long, u long. Then system.single S capital. System.single S capital is nothing but float, that is float. The C sharp keyword is float. Again, system.double D capital is again our double or lowercase letter double. Again, system.object O capital. Again, here it is object or lowercase object. Then system.char C capital, system.char or char char, char, lowercase char. Then system.string S capital, our string. This is our lowercase string. System.decimal D capital, system.decimal D capital. Then that's our decimal D lowercase decimal, simply decimal. System.boolean, B capital. Its corresponding C sharp keyword is bool, B-O-O-L, bool. Fine. It's very simple to understand. Yeah. Understanding the common language runtime. How exactly this common language runtime works. Look, understanding the common language runtime or CLR. Fine. See, in addition to the CTS and CLS specifications, CTS and common type system and CLS specifications, comma, we have CLR also. Common language runtime, CLR also, full stop. Programmatically speaking, comma, the term runtime can be understood as a collection of external services, that are required to execute a given compiled unit of code. See, a collection of external services that are required to execute a given compiled unit of code, full stop. For example, when developers make use of MFC, you know MFC is Microsoft Foundation class, MFC or Microsoft Foundation class. That is, MFC's meaning is Microsoft Foundation class, that is within bracket. To create a new application, comma, they are aware that their program requires the MFC runtime library. Bracket I have put, that is MFC 42.dll. That is it. MFC 42.dll. Close the bracket. Fine. That particular MFC runtime library is termed as MFC 42.dll. Fine. Next. Other popular languages also have a corresponding runtime. Everybody has, everything has got, every other languages, popular languages also have a corresponding runtime, full stop. VB6 programmers are tied to a runtime module like MS VB VM60.dll. That's it. See, they are tied to a runtime module like MS VB VM60.dll. Similarly, Java developers are tied to the JVM. They are tied to the JVM, that is Java Virtual Machine, and so on, like that. Java Virtual Machine, that is JVM. Similarly, Java developers are tied to the JVM or Java Virtual Machine, and so on. Fine, that's it. Yeah, CLR continued. We are continuing our discussions on CLR, that is Common Language Runtime. See, the .NET platform offers yet another runtime system. Yet another runtime system, full stop. The key difference between the .NET runtime and the various other runtimes we discussed is the fact that the .NET runtime provides a single well-defined runtime layer that is shared by all languages and platforms that are .NET aware. That are .NET aware. That's it. See, the key difference between the .NET runtime and the various other runtimes we discussed is the fact that the .NET runtime provides a single well-defined runtime layer that is shared by all languages and platforms that are .NET aware.